Good day. For this video of Learn with Rest, we will going to discuss the concepts of three physics topics: Kirchhoffs Law, Faraday's Law, and electromagnetic waves. Stay tuned as we unfold each concept. First, Kirchhoff's Law. Kirchhoff's law quantify how current flows through a circuit and how voltage varies around a loop in a circuit. There are two laws of Kirchhoff's. First, current flow in circuits occur when charge carriers travel around the circuit. Current is defined as the rate at which this charge passes any point in the circuit. A fundamental concept in physics is that charge will always be conserved. In the context of circuits, this means that since current is the rate of flow of charge, the current flowing into a point must be the same as the current flowing out of that point. That is why Kirchhoff's current law, which is the first law, states that the current flowing into a node or a junction must be equal to the current flowing out of it. This is a consequence of charge conservation. Next law, as charge carriers flowing through a circuit pass through a component, they either gain or lose electrical energy depending upon the component, cell or resistor for example. This is due to the fact that work is done on or by them as a result of the electric forces inside the components. The total work done on a charge carrier by electric forces in supply components such as cells must equal the total work done by the charge carrier in other components such as resistors and lamps by the time it has gone around the circuit once. This means that the sum of all potential differences across the components involved in a circuit loops must be zero if we count voltages across supply components as positive and across electricity using components as negative. That is why Kirchhoff's voltage law, which is the second law, states that in any complete loop within a circuit, the sum of all voltages across components which supply electrical energy, such as cells or generators, must equal the sum of all voltages across the other components in the same loop. This law is a consequence of both charge conservation and conservation of energy.
Next is Faraday's law. Any change in the magnetic environment of a coil of wire will cause a voltage to be induced in the coil. No matter how the charge is produced, the voltage will be generated. The change could be produced by changing the magnetic field strength, moving a magnet toward or away from the coil, moving the coil into or out of the magnetic field, rotating the coil relative to the magnet, etc. Faraday's law is a fundamental relationship which comes from Maxwell's equations. It serves as a succinct summary of the ways a voltage may be generated by a changing magnetic environment. The induced EMF in a coil is equal to the negative of the rate of change of magnetic flux times the number of turns in the coil. It involves the interaction of charge with magnetic field. The phenomenon called electromagnetic induction was first noticed and investigated by Faraday. The law of induction is its quantitative expression. Faraday discovered that whenever the magnetic field about an electromagnet was made to grow and collapse by closing and opening the electric circuit of which it was a part, an electric current could be detected in a separate conductor nearby. Moving a permanent magnet into and out of a coil of wire also induced a current in the wire while the magnet was in motion. Moving a conductor near a stationary permanent magnet caused a current to flow in the wire too, as long as it was moving.
Lastly, electromagnetic waves. Electricity can be static, like the energy that can make your hair stand on end. Magnetism can also be static, as it is in a refrigerator magnet. A changing magnetic field will induce a changing electric field and vice versa. The two are linked. These changing fields form electromagnetic waves. Electromagnetic waves differ from mechanical waves in that they do not require a medium to propagate. This means that electromagnetic waves can travel not only through air and solid materials, but also through the vacuum of space. Electromagnetic waves or EM waves are waves that are created as a result of vibrations between an electric field and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric fields. Electromagnetic waves are formed when an electric field comes in contact with a magnetic field. They are hence known as electromagnetic waves. The electric field and magnetic field of an electromagnetic wave are perpendicular at right angles to each other. They are also perpendicular to the direction of the EM wave. The highest point of a wave is known as crest, whereas the lowest point is known as trough. Electromagnetic waves can be split into a range of frequencies. This is known as the electromagnetic spectrum. Examples of EM waves are radio waves, microwaves, infrared waves, X-rays, gamma rays, etc. That's it for today's video. We hope that you learned something from us. Don't forget to like and subscribe. From Philip, Ja, and Jeff, always remember to learn with rest. Thank you, Wrestlings. Bye.